Jan just gave you an introduction and a deep dive into the sustainable aviation fuel. My presentation or my topic is not that complex, but it has a huge impact on the calculation methodologies and on carbon accounting and probably also on your green decisions. I will give you an overview about the calculation methodologies and also how much these methodologies have impact on your results, which will vary. I have chosen for this a flight from Frankfurt to New York with our 777, our freighter 777. It has 75 tons of freight and a fuel consumption of 60 tons. And you see here, if you're using different calculation methodologies, a spread from 410 to around about 1,000. And if you're using also the 777 as a passenger flight, it's also larger, from 500 to 2,000. So it's 4 times from here to there, so it's a big difference. And this also, the formula behind this is exactly this. It's very, very simple and easy. So you divide the fuel, the absolute fuel, divided by the transport performance with this payload times distance, and multiply it with the emission factor. And nevertheless, there are many things you have to decide. You have many parameters and also options you have to decide in order to apply this formula. And the next slide will give you an overview how much parameters are available, and you have to decide the options. I will not go into detail, but you see there are many parameters with many options. You have to decide what kind of fuel data do I take, what kind of data sources. Do I use fault data or measured data? What is the definition of cargo weight? And I will show you now shortly some 2 emission calculation methodologies which are using these parameters. This is AN 16258 in 2013, and this is the IATA recommended practice that had been developed in 2014. And for sure, because there are so many different options and they have applied differently, you will have very different results. Now I would like to go deeply into 4 of these parameters. I will start with the distance. You have to decide the distance, and you always should take the great circle distance. This is the shortest distance from one point to the other, here from Frankfurt to JFK. And it's important that you take a constant value, because otherwise you won't see, if you're looking at the specific emissions, if your more modern aircrafts or probably shark skin technology what have influence of your efficiency. If you would use kilometer flown like here, it would change. It will have 2 effects. Firstly, you can't see this efficiency, which is getting better, probably through the modern aircrafts, and also you will make the result a little bit nicer, because the kilometers in the dominator, so that will be a better value for the efficiency. Using this, for instance, will come out 410, and if you're using this, 390 gram per TKT. The scope of the emissions is also very important. You have to look if you're using or looking at the emissions from combustion during flight, or if you're also using emissions which releases from production and transportation of the fuel. And this accounts for around about 20% of the emissions, and this accounts around about 80% of the emissions. So it's very important what are you looking at. And many of the calculation methodologies are using sometimes only tank to wheel or well to wheel. Well to wheel, we say, it's a production and the transportation until the fuel is in the tank. And this one is then if it's in the tank and you are able to fly. The whole process, we say then, it's well to wheel. And as I said already, the different methodologies, then you have results which differ between 20 or 80%. The fuel conversion factor and the radiative forcing factor is also taken into consideration. The conversion factor says how you convert fuel into carbon dioxide. which is very normal. A used one is the 3.1 tons of CO2. This is used by the ETS system. It's used by the recommended practice and also by Lufthansa. But you also can use this one, or other calculation methodologies are using this. This, for instance, the ICAO calculation methodology. But then, during the combustion of production and also in the flight, we also release some of the Kyoto greenhouse gases. They are not very much. This is the reason why the additional factor will only very small. You have to multiply then in the fuel into carbon dioxide emissions only 3.1 and here 3.88. And the Science-Based Target Initiative, which was mentioned several times already, they use this factor. So we have to see also what is the right methodology, or which one you are using, or the reporting is used. And the value will rise as well if you're using and looking at the radiative forcing factor. That means that you additionally take the non-carbon dioxide effects into consideration, meaning probably water, which can make cirrus clouds. But this is a factor which still has to be researched on, because it's not 100% clear if it's correct. And so some organizations which are using them, for instance, My Climate or Atmosphere or the Umweltbundesamt, they're using the factor times 3. It still has to be cast as if this is the right number, and if you really have to look at it. This is the last topic I would like to address. It's a fuel allocation. If you're looking at the fuel on a freighter, it's 100% clear that the fuel has to be allocated to the freight on the freighter. It's 100%. But if you're flying freight on a passenger plane, you have to decide how you allocate the fuel, if you allocate it to the packs or to the freight. And there are two common allocation methodologies right now. Here, you just say you have the freight tonnage and the pax tonnage, and to take the same split for allocating then the fuel, and you will come up with a specific emission around about 800 gram per TKM. But if you are looking at this methodology, it's here differently. You add additionally to the pax weight also the seats. So for sure, the weight is getting higher, and this is very good. So for the specific emissions of the freight, it's going down from 800 to 500 or to 600. So, and this is a chart which shows it again. Here we have a IATA recommended practice. It's taking account the tank-to-wheel and the carbon dioxide emissions. Here we have the Lufthansa methodology. It's here. Then the EN 16258, looking at the well-to-wheel and CO2 equivalents. And if you add then or multiply it additionally with the RFE, you come to this number. So this is the explanation why you do have such a large spread of numbers. And since years, as was mentioned already, there are some organizations, they are working on to find a harmonized methodology. And so far as I'm informed, the ISO is under development right now, and this will finalize at the end of the year. And so it's necessary, it's possible that we have only one methodology, and that these spreads, which I showed before, is not there anymore. So it's very, very clear then what kind of methodology you're using, or what kind of number is the correct one. So, and this is clearly a plea for harmonization, and it's only finalized now.